Leadership literature is filled with fluffy, superficial content that lacks substance and scientific rigor. The sense of leadership research refers to common theoretical, methodological, and interpretation errors that compromise the integrity, reliability, and applicability of leadership research findings. In my previous videos, I introduced sin number 1, conflating behavior with perception. Sin number 2, circular reasoning. Sin number 3, mislabeling leadership. Sin number 4, lack of problematization. Sin number 5, lack of falsification. Today, I'll discuss unsubstantiated causal claims. How prevalent is this problem? In one study, researchers examined 110 leadership articles published in top leadership research journals. It was reported that between 66% and 90% of the causal claims were unsubstantiated. This suggests that the overwhelming majority of causal claims in leadership research lack sufficient evidence to support them. The studies reviewed in that article were quantitative in nature. If you read qualitative research, you should approach any causal claims with caution. Unlike quantitative research, qualitative methods such as case studies, ethnographies, or interviews do not aim to make causal inferences in the same way. While qualitative studies can identify patterns, suggest relationships, and generate hypotheses about causality, they lack rigorous control over variables and the ability to rule out alternative explanations, both of which are necessary for making causal claims. The strength of qualitative research lies in its ability to explore meaning, context, and processes rather than proving direct cause and effect relationships. If qualitative research studies make causal claims, you should treat them with skepticism because the methodological rigor required for making causal inferences is usually absent in qualitative research. To redeem this sin of unsubstantiated causal claims in leadership research, we need to first understand what causality is. Causality refers to the relationship between two things, where one thing, let's call it X, causes another thing, Y, to happen. But how do we actually measure causality? Researchers have identified 3 conditions to determine if X truly causes Y. First, X must come before Y in time. Second, X and Y must be reliably correlated, meaning the connection is not just due to random chance. And third, the relationship between X and Y cannot be explained by anything else. Typical unsubstantiated causal claims in leadership research often attribute specific leadership behaviors or styles directly to organizational outcomes without sufficient evidence to support those claims. Here is an example. You read a claim, a specific leadership style, such as transformational leadership or social justice leadership, directly causes improved organizational performance, such as student achievement in an educational leadership context. Why is this claim unsubstantiated? Student achievement is influenced by a wide array of factors, including student families' socioeconomic status, instruction quality, parental engagement, curriculum design, school resources, and community support. This long list of interacting variables makes it difficult to isolate leadership style as the sole or primary cause of improved outcomes. Without controlling for those confounding variables, the variables that influence both the independent variable, which is the cause, and the dependent variable, which is the effect, potentially distorting the observed relationship. The next time you hear a claim like this, Under the leadership of somebody, organizational performance, you insert any specific measures increased by a specific amount. Remember, it's not that simple. The idea that one individual's leadership alone caused a major change in organizational performance is not usually backed by solid evidence. If you pay attention, you will notice many leadership speeches and statements are full of those unsubstantiated causal claims. They often credit a single leader for very complex outcomes. There is much more at play than just one individual's behavior. To conduct a causal analysis well in leadership research, here are 10 recommendations for practices that ensure rigorous and reliable results, which are necessary to substantiate causal claims in leadership research. First, control for omitted variable bias. Here, omitted variable bias means that a relevant variable that influences both the independent and dependent variable is left out of the analysis. This omission can lead to incorrect conclusion about the relationship between the variables being studied. For example, when studying the impact of transformational leadership on employee performance, you need to control for factors that might influence performance independently of leadership, such as employee skills, knowledge, ability, motivation, and job characteristics. Those variables, if omitted, could distort the relationship between leadership style and performance, which leads to inaccurate results. If you are unable to identify or measure certain control variables, there are other approaches you can use, such as panel data or external sources of variance. Panel data refers to data collected over time on the same subject. With panel data, you can observe changes over time and control unobserved factors that are constant for each subject. Panel data helps in isolating the effects of the independent variable by controlling for unmeasured variables that don't change over time. For example, if you cannot directly measure employee motivation, using panel data can help track changes in performance over time while controlling for unchanging personal attributes like employee personality traits. Let's talk about external sources of variance, also known as instruments in statistical analysis. What are they? Instruments are variables that are related to your independent variable but don't directly influence your dependent variable except through that independent variable. Using instruments help you build a more accurate model by accounting for hidden factors that might influence both the cause and the effect in your study. With panel or multi-level data, always model fixed effects. But what does that mean? The fixed effects help you control for unobserved factors, things you cannot measure directly, but that may still influence your results. You do this by using something called dummy variables. Dummy variables act as a placeholders for those unobserved differences so that they don't distort your analysis. Let's say you are studying leadership performance across multiple organizations over several years. Each organization is unique. Some might have more supportive culture, others might have different resources, and those factors can influence your results. To account for those differences, you'd create organization-specific dummy variables with a separate dummy variable for each organization. For example, an organization A dummy would be coded as 1 for any data related to organization A and 0 for other organizations. You would follow the same process for the rest of the organizations. By including those dummy variables, you are controlling for unmeasured organization-specific factors like organizational structure and budget that could influence leadership performance but are not directly observed in your data. This ensures the effect of leadership performance is measured accurately without interference from other observed differences. To get accurate results in your research, it's important that your independent variables are exogenous. Exogeneity means that your independent variable is not influenced by any other variables in your model. Its changes are completely independent, and it directly influences the outcome. If your independent variable is endogenous, meaning it is influenced by other variables in your study, your results can become unreliable. To correct this, you use instrumental variables, which influence your independent variable but don't directly influence the outcome, except through the independent variable. For example, let's say you're studying how leadership training influences leadership effectiveness. If the decision to attend leadership training is influenced by factors like the leader's achievement, motive, or personal connections, the training becomes endogenous, and this could distort your results. To fix this, you can use random assignment to training as an instrument. Since random assignment is unrelated to individual traits, it ensures that leadership training remains exogenous. This allows you to isolate the true effect of training on leader effectiveness without interference from other factors. However, in leadership research, it's often very challenging to implement random assignments due to logistical constraints or ethical concerns. As a result, researchers often need to rely on other strategies like natural experiments or statistical techniques to find valid instruments that can mimic the effects of random assignments. A common challenge in leadership research is non-random selection. If leadership roles were not randomly assigned, or if your sample does not represent the broader population, your results can become inaccurate. But there are ways to correct for this. To address this issue, you use techniques like difference in differences or propensity score matching. Those methods help ensure that your comparisons between groups are fair, even when random assignment is not possible. Let's say you're comparing the effectiveness of male leaders and female leaders. If men and women were not randomly assigned to leadership roles, and factors like experience, education, or professional networks may influence who becomes a leader, this can bias your results. In this case, you can use propensity score matching to account for non-random selection into leadership positions. How does it work? You match male and female leaders based on similar characteristics, like years of experience, education, or professional networks. By using techniques like propensity score matching, you can correct for non-random selection and make your findings more reliable, even when random assignment is not an option. This ensures that your analysis provides a clearer, more accurate understanding of leadership effectiveness across different groups. When using instrumental variables in your research, it's not enough to just choose a good instrument. You also need to make sure it's valid. This is where over-identification test comes in. One common over-identification test is the Sargent test. This test helps you determine if the instrument you are using are properly isolated from any other influences that could distort your results. Let's say you're studying how leader charisma influences follower performance. You've chosen an instrument, perhaps the leader's involvement in a specific leadership training program. But how do you know that this instrument is truly valid? To validate your instrument, you run the Sargent test. This test checks if the instrument influences the dependent variable, follower influence, through anything other than leader charisma. If the test passed, you can be confident that your instrument is solid and your model is reliable. By running over-identification tests, you add an actual layer of reliability to your model, which ensures your results are reliable. So whenever you use instrumental variables, remember to validate them with an over-identification test. It's a critical step in making sure your analysis holds up. A common problem in leadership research is measurement error. When your independent variables are measured with error, it can bias your results and make your analysis less reliable. One way to handle this is by using errors in variables models, which help account for the measurement error in your data. Another approach is to use instruments, just like we talked about earlier, to correct for this bias. For example, you're using leadership style questionnaire to study the relationship between leadership behavior and employee job satisfaction. Those questionnaires may not always capture leadership style perfectly. People's responses can vary based on their mood, interpretation, or even how they perceive their own behavior. Recall sin of leadership research number 1, conflate perception with behavior. All those factors create measurement error. To adjust for this, you can correct for measurement error by constraining the residual variance. Essentially, this means adjusting your model based on how reliable the questionnaire scale is. If your leadership style questionnaire has a reliable score of 0.80, that tells you it's capturing 80% of the true leadership style, while 20% is noise or error. You can then adjust your model accordingly to account for that error. By doing this, you reduce the impact of measurement error, ensuring your analysis gives you a clearer and more accurate picture of how leadership really influences employee job satisfaction. Another issue to watch for in leadership research is common method bias. This happens when both the cause and the effect are measured using the same method, which can lead to biased results. But how do we avoid it? One of the best ways to prevent common method bias is to use different sources or methods to measure your variables. But sometimes that's just not possible. In those cases, you can use instruments to get consistent, unbiased estimates. Let's say you are studying the relationship between perceived leader support and employee job satisfaction. If you measure both variables by asking employees about their perceptions, you could end up with the common method bias. Employees may rate both leader support and their job satisfaction similarly just because it's the same survey, not because there is a real link. To prevent this bias, you could use leader ratings of support as an instrument. Instead of relying solely on employees' perceived support, you ask the leaders themselves to rate the support they provide and then ask employees to rate their job satisfaction. Since different ratings come from different sources, they reduce the common method bias. In leadership research, it's important to make sure that the conclusions you draw from your data are consistent and reliable. One key to this is checking whether your residual are identically and independently distributed. Residual represent the error in your model, the difference between what your model predicts and what actually happens. For your analysis to be consistent, those errors needs to be identically and independently distributed, meaning they should follow a similar pattern across all observations and not be influenced by one another. For example, you're studying employee productivity in different teams across an organization. If the productivity of employees within the same team is more similar to each other than to employees in other teams, this could lead to within group correlation. This means your residual are no longer independent. To handle this, you should use cluster robust standard errors, especially when you are working with panel data. Cluster robust standard errors adjust for correlation within groups. This ensures your results are still reliable. If employees are nested within teams, using cluster robust standard errors to account for the fact that members of the same team may have similar behaviors or productivity levels. This ensures that you're not underestimating or overestimating the impact of leadership or any other variables you are studying. As a default, you should always use robust variance estimators, which adjust for issues like unequal variances in your data. And when working with nested or panel data, switch to cluster robust estimators to account for those within group correlations. When working with mediation models, it's important to check for endogeneity. This happens when one of your variables is influenced by other factors in your model, which leads to unreliable results. So, how do we handle this? A mediation model is a model where one variable, the mediator, explains the relationship between the independent and dependent variables. To ensure your results are accurate, you need to correlate the disturbances, essentially the unexplained errors between your potentially endogenous variables. To be actually sure, you should run a Houseman test to check for endogeneity. The Houseman test tells you whether any of the variables in your mediation models are influenced by outside factors that could distort your findings. Let's say you're testing whether transformational leadership influences employee performance through motivation. In this case, motivation is a mediator between leadership and performance. But what if motivation is influenced by something else, like leaders' personal relationship with the team? That makes motivation an endogenous variable. To account for this, you need to correlate the disturbances, the errors of leadership and motivation in your model. This allows you to control for any hidden relationship between them that may skew your results. Next, run a Houseman test, which will tell you if the relationship between leadership and motivation is influenced by external factors. If the test shows endogeneity, you'll need to adjust your model to get more reliable estimates. Finally, choose the right estimators for your model. This step is key because the estimator you choose can significantly impact the accuracy and the reliability of your results. In some cases, you might be tempted to use full information estimators like maximum likelihood estimation because they use all the available data at once. However, full information methods can sometimes lead to biased results, especially in complex models with a lot of moving parts. So, how do you know when to use maximum likelihood estimation? A good rule of thumb is to always compare the results from the maximum likelihood estimation with a limited information estimator, like two-stage least squares. Two-stage least squares is often more robust when dealing with complex models that include endogenous variables, where one variable may influence another in unexpected ways. Let's say you're estimating a complex leadership model that looks at relationship between transformational leadership and employee performance. If there is a possibility that employee performance influence leadership behaviors, making the variable endogenous, maximum likelihood estimation may not be the best choice. In this case, you should compare the results from maximum likelihood estimation with the results from two-stage least squares. Two-stage least squares breaks the estimation process into two stages. First, isolating the independent variables to handle endogeneity. If the results from two-stage least squares differ significantly from maximum likelihood estimation, it is a sign that maximum likelihood estimation might be giving you biased estimates. As you can see, there are rigorous methods you can use to ensure your causal claims are substantiated. Following these 10 practices will help you not only improve the quality of your own leadership research, but also contribute to raising the overall standard of leadership studies. This, in turn, will lead to more actionable insights and evidence based approaches in leadership development and organizational science. Remember, as leadership researchers and practitioners, we have a responsibility to ensure that our causal claims about leadership are well founded and can withstand rigorous empirical scrutiny. Only then can we truly advance our understanding of leadership and its impact on individuals, organizations, and society as a whole.